and welcome to my short presentation about how to scale PHP applications with RabbitMQ. First of all, let me introduce myself. My name is Radu Buzea, and I'm a software architect and a Scrum Master for a project called Mercury. It's developed in the IT department from Ubisoft Romania. And today I will try to very briefly to present to you how to scale applications with PHP, but not only with PHP. PHP because we are using in Mercury PHP, so that's my main knowledge on how to use RabbitMQ. And I have some topics. We will discuss about message queuing. We will discuss what is inside RabbitMQ. I will try to present to you how to connect from PHP to RabbitMQ and how to scale with RabbitMQ. So, what is message queuing? What is a message queuing system or a message-oriented middleware? Those are tools that allows distributed applications to communicate and exchange data by sending and receiving messages. And you can find on the market different tools that are doing that. Apache Kafka, ActiveMQ, ZeroMQ, and my main subject today, RabbitMQ. So, why would you need message queuing? There are many reasons. One of them being to process background jobs. When your application has to process very heavy data and you don't have time and resources to do that, you can use RabbitMQ to postpone some messages or to process them later when your application is able to do that. When you want to create an event-based communication, let's imagine that you have in your infrastructure, you have different applications and you want to send a message from one to others, notifying about an event. So your application will post that event, that message, and all the applications that are connected to RabbitMQ will consume that message and they will do some actions on their side. Integrations. So when you have two different applications written in different programming languages and you don't want to create a bridge between them, to communicate between them, you can use RabbitMQ because this is what RabbitMQ is doing. It offers you a bridge, so you can do that without spending too much time building a bridge between those two applications. 2 or 3 or many or however. If you want to schedule some actions, so what that means, let's say you have a very specific time frame when your system needs to be up and running, and you don't want to process too many data because it will probably take too much time and too much resources. So you can postpone them for later and put all the messages, all the requests in a queue, and later when your server it's available, you can run consumers that will consume messages and that will process the data. And of course, scaling. This is also one of the subjects that I will discuss with you today. Scaling, you will figure out what scaling means with RabbitMQ a bit later. So, what is inside the Rabbit? I'm assuming that you can see something like this, a skeleton, some organs probably, and for sure a very small brain. Those rabbits from Ubisoft, I don't know if you know them, but they have a very small brain. A bit stupid. But not really. What is RabbitMQ? RabbitMQ is a multi-system message broker. It was written in Erlang, OTP framework. Why Erlang? Because I don't know if you know what Erlang means. Erlang was created by Ericsson at some point and offers you support for communication processes. So it was a good choice for building RabbitMQ with Erlang. And I said that it's a multi-system, so you can have it on Unix, Linux, Mac, and Windows. RabbitMQ is a polyglot message system. You can find libraries for Python, .NET, Perl, PHP, whatever, you name it. You can, even on the RabbitMQ website, there is a huge collection of libraries for different programming languages. And it's a multi-protocol system. RabbitMQ natively implements AMQP. This is a protocol designed especially for message queuing. It implements AMQP 091, sorry. But if you want to have AMQP 1, you can have a plugin that enables you to use it. Also, you can use MQTT or Stomp through some plugins. But natively, if you are using RabbitMQ right now, probably you are using AMQP 091. So, how does RabbitMQ work? Let's imagine you have a producer. As I said, you can find anything you want on the RabbitMQ website for different programming languages. As long as your programming languages know how to handle TCP-based protocols and knows how to generate a string, then you can publish a message. The message will go to an exchange. The exchange, it's something like a postal office. And I'll explain to you how it works a bit later. And from the exchange, through some bindings, you can send messages to queues. So you can also imagine that as your inbox folder, where you have your emails coming, and you want to set up some rules to move the messages to specific folders when they are received by your email client. So this is how an exchange bindings and queues are working in a messaging system. And to the queues, you will connect consumers that will consume messages one by one, processing the data. So what is in the middle, the exchange, the bindings, and the queues, represents a message broker. So that is inside Rabbit. Here are some other features that you can find in RabbitMQ. So if you want to, it offers a very large set of features if you want to trade performance with reliability. It's persistent. It offers support for delivering acknowledge, for publishing confirmation, for different other stuff. It has a very flexible routing. So an exchange, it's like an algorithm, let's say, that's based on your criteria will direct messages from different queues. Natively, it implements 3 exchange types: direct, fan out, and topic. But through some plugins, you can have your own routing system, your own exchange type, and you can use that. Clustering and federation. Clustering and federation, I don't want to go too deep in this subject. It's good for scaling also. And because of clustering, you will be able to have high availability queues. Let's imagine that you have in a cluster, you have different servers connecting to each other, different RabbitMQ servers connecting to each other, and you will have the same queues and messages on all those servers. And if one of those servers is falling down, your messages will be there. You will have them there, and you can process them later when your application is back online. It has a management UI. It's a web-based management UI where you can see what's happening with your messages, where you can see what's happening with your queues, how many messages are consumed, how many messages are rejected, how many messages are reposted, republished, how many consumers are connected, and what's the status of those consumers. And also you can trace messages. You can see what's the status of a message from the beginning to the end, from the moment that message goes to the RabbitMQ and until the message will be consumed by a consumer. And also, as I said before, it offers a plugin system. You can use, as I said, Stomp or MQTT as protocols if you want, as messaging protocols if you want, through some plugins. You can create your exchange type if you want a custom routing system. And speaking about exchange types, here are those three. I will start with the direct exchange. This is very simple. All the messages are going to a specific queue. When you send the message, you specify the queue that needs to receive that message. So you have messages going to specific queues and then to specific consumers directly. The second one is fan-out exchange. This is very, very good for an event-based communication application. So you can send a message to RabbitMQ, to an exchange, and the message will be copied, duplicated, and put it in different queues for different consumers. And you can process the information later. As I said, it's good for event-based because it doesn't matter what kind of application are consuming the messages. You can notify them about something happening in your infrastructure. And the last one, it's the topic exchange. This is a complex one. It's a mixture between direct and fan-out with some kind of custom routing. So in this example, I said that, okay, let's build a log system. It's stupid, but let's build a log system. You want to tackle some information. So you want to see what's happening with the errors, but you also want to store everything in a single place. So I defined three queues, one that will receive info logs, one that receives error logs, and one that receives everything. The first one, it's a warning. It's not an info, it's not an error. It will go directly in the global log queue. The second one, it's an info, so a copy of the message will be posted in the global log queue, and another one will be posted on log info to be processed by a specific consumer. And of course, let's imagine that we have an error. Again, a copy will be posted in the global logs, and another one will be sent to the log errors queue for different processings. So how to communicate with RabbitMQ from PHP? Actually, there are a lot of libraries and extensions. One of them that we are using in Ubisoft, it's PHP lib. It's one of that. It's also given as an example on the RabbitMQ site. Here is the way that you can create a producer in PHP. It's not so complicated. This is a basic one. Probably if you want to do some fancy stuff, you will need to write more code than this. So first you need to create a connection. It's like a database connection or a FTP connection. You need to specify the server name, the port, username, and password. Then you will need to connect to a channel, to a communication channel. And from that communication channel, you need to declare a queue. In this case, the queue name is hello. It's better to declare the queue here, even if the queue has been declared. It's better to ensure that the queue exists and you can send messages to that queue. And then you can create a message, an MQP message, an entity. In this case, with just a simple text. And you can publish that message to the channel for that queue. At the end, you need to close the channel and connection. On the other side, you will need to have a consumer. So to write a consumer, it's pretty much the same thing as for the producer. You need to initialize a connection and a channel. You will define a queue. It's better to define a queue to make sure that the queue exists. You will have a callback function that will be used later when messages are processed. Then you will register your consumer to consume messages from the hello queue and iterate at the end so you can keep your script running and consume messages. And in the callback function, when you will receive a message, it's an object that contains the body. The body is a simple text in this case. It can be a JSON, XML, or even binary data. And when you are done processing the data, you can acknowledge that the message was received and processed. Or you can do the different other things here. You can requeue a message if you want. post another message or so on. Or you can have a response back to the server if you want to have something like remote procedure calls with RabbitMQ. So when you need to scale, basically when your application is overloaded, this is the moment when you need to do something, and if you don't want to rewrite everything, it's better to scale it probably by starting more consumers of the same type and put them in the chain, and they will consume messages and they will speed up the process of your application. Or you can scale by changing something in your application. You can add new functionalities. You can replace something in a consumer that is not performing very well. You don't need to rewrite everything. You don't need to create a new build. You just create a new consumer, a small application. You take it out from RabbitMQ, put another one there, and everything it's back to normal and probably better. So how to construct an application with RabbitMQ so you can scale? So let's imagine that we have 3 types of consumers. But we know that on the green one, the products, will have a very heavy load. So I will initiate many consumers on that type and less consumers on different other types. And of course, I can set different kind of bindings between queues, and messages will be sent to different consumers in different ways. From your application producer, you send a message, and that's it. And if you want to make sure that your application is still up and running, your consumers are still up and running, you can put a supervisor to control what's happening with your consumers. So, in Mercury, we are doing something called remote procedure calls. RabbitMQ, it's mostly asynchronously done. Everything it's done asynchronously in RabbitMQ. So for remote procedure calls, it will be a tricky stuff to do because your application, your producer will need to wait for the message to be consumed and processed by one of the consumers. To do that, probably a good idea is to have a caching layer that will check if your message or your request is still there in the caching, and you can take it from the cache and send back the response very, very fast. If the information is not in the cache, then you post a message to RabbitMQ that goes to a consumer, processes the data, sends back the response, and then the same consumer can save the information in the caching for the moments when you need to have the same request and to give the same response. So it was very brief. I tried to fit in my time. Thank you very much. If you have questions, I can take a few, just a couple. Yes.
Yeah, we got time for questions. But personally, I have a question, which is,
okay,
how does RabbitMQ compare to some of the other kind of queuing systems?
Sorry?
To any of the other queuing systems? How does it compare? What makes RabbitMQ stand out?
First of all, it implements MQP, so MQP fully, without any kind of changes. There are some parts from the MQP that are not apart from RabbitMQ, but you will have that only. So I don't know exactly how it stands up. I don't know, I didn't play with others, so I can pronounce myself. I used RabbitMQ. It was a good solution for me at that point. For us as a team, we selected it. But from what I understood is because it's written in Erlang, and because Erlang enables you to have to build a communication process very easily. It's light, it's very easy to scale, and it does what it needs to do without doing something else.
Okay. Any other questions from the audience? Oh, we have one over there.
Hi.
Go ahead.
Just a second. Okay. I would like to ask you regarding the integration between RabbitMQ and Java messaging service, because that is a very use protocol on market, and it will be very helpful if the integration is somehow simpler. In order to, I don't know, replace some existing MQ integration with RabbitMQ.
Unfortunately, I cannot answer this question because I'm not an expert in Java, so I don't know exactly what to do with Java. But if you want, I can try to find out how it stands. How can you?
Okay, then keep in touch. Thank you.
Awesome. We have another question there behind you.
Hello. My question is about the caching system. Can you go into a bit more detail into that, and why do you need it when Rabbit is sort of a caching system, or actually
as I said, in RabbitMQ everything is done asynchronously. You will when RabbitMQ will receive a message, the message goes to a queue and stays there until a consumer is able to process it. So this will add, sometimes this will add a very large amount of time here. So you will not be able to respond in time. You can increase the number of consumers, so you can clear the queue very, very fast, but this is not a solution. So you can do that, but it's better to, if you see that there are requests that are the same in a certain period of time, to put them in a cache. So you will not need later processing. You will just take the information from the cache and that's it.
Okay, I think we got time for one last question.
Yes, if you want to ask me more questions, you can find me at the Ubisoft stand.
We're just going to do one last one.
Okay. Yes?
I was thinking about using RabbitMQ for an event storming. I mean, you have a producer and the consumers, but the consumers would need to give an answer back, and the original event producer would need to do some job on response to that. Can you have multiple producers, or the consumers can be producer themselves?
Yes, you can do that. That is the remote process calls. But again, because it's a message queuing and everything is done asynchronously, it's better to avoid that. If you are doing that, we are doing that in our projects in Ubisoft, but if you are doing that, it's better to build very carefully your application. And I can explain to you later, if we can discuss about that, how to do it. It's not so complicated, but requires a bit of attention.
Okay,
but it's possible.
Big round of applause.
Thank you very much.
Thank you. Thank you, Radu.